Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 7E. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. We are honored to have you all with us. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event was held yesterday and is being held today, that is 21st and 22nd of Feb 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 2 minutes for questions and answers. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we get started, I would like to introduce you all to the chair for this session, Dr. Vijeta Kumawat ma'am. Dr. Vijeta Kumawat is a Deputy HOD and Associate Professor in Department of CSE at Jaipur Engineering College and Research Center. She has 17 years of teaching experience as Head of Department and Associate Professor. She has 2 Indian patents. Her expertise is in ADHOC networks, wireless sensor networks, and Internet of Things. She has 45 international and national publications and has attended 50 seminars and workshops. We are really delighted to have you with us here today, ma'am. I would like to request now, ma'am, to kindly deliver a welcome address.
Thank you, ma'am. Thank you so much for this wonderful introduction. Uh, Thank you for inviting me as a session chair for this conference. And I congratulate all the participants and my best wishes to present their research work and best of luck for the presentations. Thank you.
Thank you, ma'am, for your kind words. Without further ado, I would like to start with today's session. Calling up first, I would like to request Ma'am Shaima Bokri to kindly present her paper titled B- BER topic LDA model for a bidirectional recommendation system towards matching jobs in job seeker. Ma'am, do we have you here with us? Anisha, I think she is not here. Since since we do not have her here with us yet, we'll move to the second participant for the session, Sir Stephen Bruner. I'll request Sir to kindly present his paper titled Deep Ensemble Novelty Detection and Fault Identification in Multivariate Data. Yes, your screen is visible. You may start.
Sorry. First of all, hello everybody and welcome to my presentation. Can you hear me?
Yes, we can hear you.
Oh, thank you very much. So then I will start. Welcome to my presentation about the deep ensemble novelty detection and fault identification in multivariate data. So first I will start with the outline, then we take a look at the background, why we did this work. Then I will propose you the proposed architecture, deep ensemble novelty detection, and 2 fault identification methods. The next step will be taking a look at the method and results, and last but not least, we have short conclusions. First, with the background. Safety critical systems require continuous monitoring in order to detect abnormal behavior. And this type of abnormal behavior can lead to injuries, environmental damage, or significant financial damage. And the challenge in this setup is that we mostly have little knowledge about the unknown states that can lead to this type of injuries or damage, but we have a lot of knowledge about the known states which don't lead to abnormal behavior. The next challenge is typically a safety critical system uses a combination of sensor information, and our goal of this setup is to detect this type of abnormal behavior in early stage based on a set of sensors. And the next goal is also to identify the fault causes of this abnormal behavior. And so the novelty detection considers the detection of abnormal or novel states based on known states. And we also want detecting novel states independent of the type of multivariate data. As you can see here, independent, for example, of stationary, non-stationary time series, tabular data, or vectorized images. And the fault identification consists of the correct identification of the fault causes of the detected abnormal behavior. And now to our architecture. The deep ensemble novelty detection was created to handle this problem. It consists of an complete autoencoder that captures the data structure of the known states, and it consists of a soft voting classifier for the detection of known and novel states based on the quadratic reconstruction error. Both components are only trained with known states, and the idea behind this architecture is that the quadratic error for novel states have typically a way higher value than the known states, since we only train the autoencoder based on the known states. And the first component, the autoencoder, captures the structure of the known states. It encodes the input space of the multivariate data to a latent space, and the decoder reconstructs the input from the latent space. And this autoencoder is then created with different neural network types, as you can see here. And the second part of the architecture is the novelty ensemble, and where the detection of known and novel states are based on only known states. And the decision for detecting a known and novel state is typically performed based on the log likelihood function, where we use the quadratic reconstruction error as input. And the soft voting classifier consists of 3 state-of-the-art novelty detection methods, which were able to detect novelties with a high performance. And the last component of the novelty ensemble is the soft voting mechanism, where the final prediction is derived based on the mean prediction probabilities of each of these methods. And now I will show you the architectures for the fault identification. The first one was the decision tree for learning hierarchical fault, the hierarchical fault tree structure for prediction of our novelty detection model. This type of decision tree is intrinsic interpretable, and the decision rules, as you can see here, are derived on the quadratic reconstruction error, which are mapped on the predicted labels of the novelty detection method. And this threshold of this tree can be used for the identification of fault causes. And this type of method is also applicable to any type of novelty detection method to identify default causes. And the second method is the deep feature importance, and the idea behind it is derive saliency maps for tabular data, where we feed back the predicted class to derive the most important features for a prediction. For this purpose, we use a surrogate neural network to learn the decisions, and then we map the quadratic reconstruction to the predicted labels. And last but not least, we derived a feature importance score based on the normalized gradients, which indicate the feature importance. So therefore, a feature importance close to 1 means this feature was the cause for the novelty, while close to 0 indicates no influence. This type of method is also applicable for any type of novelty detection method. And based on these proposed architectures, we derived a method for assessing the experiments and the previously introduced architectures. And this method contains 3 main tasks: the dimension reduction, where we later then assess the latent space of the dimension reduction method. For the second, the novelty detection, we assess the novelty detection performance with the help of the area on the receiver characteristic curve and the Auroch score. And last but not least, for the fault identification, we assess the true positive rate for the rate of correct identified faulty features and the false positive rate for the rate of incorrect identified faulty features. Based on this setup, we derived an experimental setup where we compared our new architecture for novelty detection to several state-of-the-art novelty detection methods, and also our previously introduced deep Gaussian mixture model. In total, 140 experiments were conducted, which were a combination of 7 novelty detection methods, 4 dimension reduction methods, based for 5 different data sets. And for default identification, we only assessed it for the Gaussian distributed data because we only had default location available for this type of data set. And now the results of the novelty detection. In all experiments, it was shown that the deep ensemble novelty detection achieved a stable and very high performance across all types of multivariate data. And it was also shown that independent of the used dimension reduction method, this performance was achieved. The state-of-the-art novelty detection methods didn't achieve a stable performance independent of the type of multivariate data. And it was also shown that the autoencoder leads to slightly better performance than the principal component analysis if we use the autoencoder for the dimension reduction. And for the visualized dimension reduction method, it was shown that the autoencoder is better able to separate the known from the novel states because it has less overlapping between the known and novel states, and it led also to small groups, while the PCA mostly separated the 2 states without clear boundaries and with no clear grouping. And in the dimension reduction part, it was shown that the separability strongly influences the novelty detection performance. And the results for the fault identification, it was shown that the performance for the decision tree is heavily dependent on the depth of the decision tree. Therefore, you have to find a suitable trade-off between the complexity and accuracy. This type of method also enables an easy human understandable rules for default identification, where the path indicates the decision rule for the respective prediction. In the experiment, it was also shown that the too great depth can lead to less intuitive decision rules, and that the depth size must be selected for the respective task. For the deep feature importance, it was shown that it is able to achieve a very high true positive rate while keeping the false positive rate on a decent low level. An accurate score for this method is also heavily dependent on the settings of the gradient descent to derive the deep feature importance. Therefore, a suitable setup must be found and suitable thresholds for assessing default causes, and depending on the risk, you should use other thresholds. For high-risk application, you should use a very low threshold, while for low-risk application, you can go for higher thresholds. And now I'll give you the conclusion about this publication. So it was shown that for the novelty detection, the deep ensemble novelty detection achieved a high and stable performance independent of the type of multivariate data. The state-of-the-art methods still achieved acceptable performance for some tasks, but they were less independent of the type of multivariate data. For the dimension reduction, it was shown that the nonlinear methods, as the autoencoder, separated the known and novel states only with minimal overlapping, and it also improved the novelty detection performance. The principal component analysis lead to more overlapping between the two states, and for the fault identification, it was shown that the both proposed methods were suitable for an accurate fault identification, while the decision tree enables a fault identification based on hierarchical rules, while the deep feature importance achieved a very high performance while keeping the false
This is a
positive rate
general 10 minutes.
very
Bye.
low. And now I will switch to the question and answer part.
Yeah. Can you, very nice presentation, Stephen. And you present a very good work in your area. The dimension reduction, novelty detection, fault identification. What basic, actually, I want to ask that what is the basic challenges you are facing during the research in this area?
The basic challenges so the hardest challenge was to find good data for the assessment, for assessing the safety critical system, because a lot of this tabular data do not represent safety critical system. Go back to the image. So for example, the stat log pump sensor, these are mostly data sets that represent more safety critical systems. And the MNIST data set, for example, these typical state-of-the-art data sets weren't that significant for the results. And for default identification, the hardest part is to find a data set where you have default location.
Ma'am,
Sorry,
you're mute.
I think you're muted.
Okay, thank you, Stephen.
Thank you, sir, for your presentation.
Thank you very much for your time.
Coming up next, I would like to invite Sir Akash Ghosh to kindly present his paper titled Enhancing Healthcare User Interfaces Through Large Language Models Within the Adaptive User Interface Framework. Do we have you here with us, sir?
Yes, I'm here. I'm just starting to share my screen.
Yes, you can.
Good afternoon,
Yes,
everyone.
it's visible.
My name is Akash Ghosh. I'm a recent graduate in Bachelor's of Computing Science from Thompson Rivers University. Today, I'm presenting a paper on enhancing healthcare user interfaces through large language models within the Adaptive User Interface Framework. Hereafter, I'll be referring to large language models as LLMs and the Adaptive User Interface Framework as AUIF. We will be starting with introduction, then objectives, and passing through the significance, the core stages of the framework, the role of LLMs within the framework, the experiments and results, discussion, and finally the conclusion. The digitalization of healthcare has introduced numerous platforms. This is why we can see that more and more people are keen to access their medical information from the comfort of their own homes. The problem is that current platforms are static, and these static platforms often result in a suboptimal experience for users and can hinder the effective delivery of healthcare services. So they do not cater to the diverse need of different users. As a solution, we are introducing the Adaptive User Interface Framework, and today we will discuss the integration of LLMs within this framework for dynamic, personalized healthcare user experiences. The objectives of this research is to investigate LLMs within the framework for healthcare user interface enhancement. Also, we would want to redefine the user interaction by providing real-time personalized adjustments. Personalization is crucial in healthcare. Current static platforms often result in the suboptimal experience, and this is why the AUIF represents the integration of LLMs for user experience improvement and real-time HTML content adjustments, marking a significant step forward in intelligent user interface design. This has the potential to improve patient engagement, satisfaction, and adaptability to diverse user behaviors and preferences. Let us take a look at the core stages of the framework. The first stage is preference detection, where by utilizing advanced behavioral analytics and heuristic algorithms, the AUIF can identify potential areas of improvement or customization, which leads to the creation of problem statements which are structured and will be passed on to the next stage, where potential solutions will be explored. These solutions will be ensuring contextual relevance and cultural appropriateness to the problems. In the next stage of the framework, a multi-criteria decision-making algorithm will help in the selection of one or more optimal solutions, which will be integrated into the application interface in the solution execution stage. Post-implementation, we have the feedback loop, which is one of the most important part of this framework. It will utilize both direct and indirect feedback to access the efficacy of the adaptations and inform subsequent iterations. So moving on, we want to look at the roles of LLMs within this framework. In the first stage of the framework, the user behavior is translated into structured problem statements, which are then passed to the LLM for it to interpret. The LLM then creates an array of potential solutions for the identified user challenges. In the third stage, these proposed solutions are evaluated and the most effective approach is determined and implemented in the user interface at the last stage. So now I will show you a couple of practical examples using the three experiments that we have performed in this investigation. Our first experiment was to overcome language and cultural barriers. So here our hypothetical user is Maria, who is from a Latinic or Hispanic background. She has trouble reading content which is in English. And as you can see, she has come to this web page where it talks about 5 common health conditions that affect the minorities in the population. Here in this website, the entire content is in English. And as you can see, they are not talking about just one minority. They're talking about many minority communities here. So the framework detects Maria's personal preferences and her needs, and it creates this, just a second, and it creates this enhanced web page for Maria. As you can see at the top of the web page, we have a summary generated by the AI. This summary is specific to Maria's community, And point to be noted is none of this content has been created or generated by the AI. This is information that has been taken from the web page itself, because we do not want to provide any new information which is not verified by the web page itself. The only change that the AI does, it rewords the content just to make it easier for Maria to understand, and it brings it to the top of the page, so it's easier for her to just digest the information. Also, to help her further, it adds a Google Translate button here, so Maria can easily click here and change the entire content of this page to Spanish. So as you can see, she can now easily understand the information on this web page. Moving on to our second experiment. Here we are trying to improve the accessibility of this web page for senior citizens. So here our hypothetical user is Eleanor, who is a 75-year-old retired teacher, and she has vision issues. So it is very difficult for her to read text, which is very small. As you can see, the text here is quite small. She also has difficulty finding options and buttons which are cluttered. So as you can see here, the text is small and very cluttered. So even if it is not a problem for us, but for someone at the age of Eleanor and with her visionary issues, this can prove to be a challenge for her. The framework detects Eleanor's needs and it redesigns the web page to this. So as you notice, it's very clear that the information is much more visible now. All the buttons have been enlarged by the framework. Even the small buttons here, the text is more visible. And it even has added more white space and padding to the elements so that it is easier for Eleanor to navigate through this web page. Additionally, the framework adds a button here called Voice Guidance. Using Google Speech, upon clicking this button, Eleanor can have more details about the web page.
Welcome to Alberta Health Services. To navigate, click on the highlighted links. For more information, hover over the elements with tooltips.
So as you can see, all these things are very helpful for Eleanor, and she can now easily use this web page. So moving on to our third experiment, we have our hypothetical user, Mia, who is a medical student. She is trying to learn new medical information and stumbles upon this web page. But this web page has a lot of complex terms here, as you can see. So Mia is just a student and is trying to learn all these things. So for her, when she faces one of these terms, she has to Google it or search it in the dictionary, or just has to find a way to understand the meaning of this term easily. To solve this and make life easier for her, the AUIF recreates this web page to something like this. And as you see here, all the complex terminologies have been highlighted by the framework. Also, when Maria hovers her mouse button upon the highlighted fields, she can see a one-line definition of this term. So not only this makes her very easy to navigate, it also helps her very easily to digest all the information. Because now whenever she finds a new term, so let's say like this, she can just hover on top of it and understand what this is. And as you can see from the results that we have obtained from the experiments, we have performed each experiment for 20 times, and we have seen the average response time using the GPT-4 model. As you can see for experiment 1, the average was around 1 minute 40 seconds, for 2, 1 minute 15, and for 3 was 3 minutes. Also, the number of prompts needed for each experiment was from 1 to 4 prompts, and this is actually a good number and can be further improved by optimizing the model. Even the success rate for the experiment was between 80% and 90%. So Now, the AOIF demonstrates a marked enhancement in the capability to tailor user experience in real time, responding to the nuanced demands of individual users, which will result in a higher degree of compliance
This
and
is a gentle
satisfaction.
10 minutes reminder.
Thank you. So the challenges that we faced during this investigation was variable user feedback quality, privacy concerns, and computational requirements. The proposed solutions that we had for these challenges is targeted surveys to improve the feedback quality, anonymization techniques to reduce privacy concerns for users, and model optimization to improve the efficiency of the model. The AUIF contributes to personalization at scale, predictive user modeling, and real-time adaptability of medical web pages. Our next phases include extensive human testing, iterative development, and addressing the challenges that have been faced. Our vision is to create an adaptable, intelligent, and user-centric digital health environment that is capable of meeting the intricate tapestry of users' needs from across the globe. Thank you for your time. I'm open to questions.
Nice presentation, Ghosh. And
Thank you, ma'am.
the experiments results you have shown in your presentation, right?
I did not catch
What
what
is
you just said. Could you repeat kindly? Hello, ma'am. Could you kindly repeat your question?
There's
I did not catch
there's
it.
some error in her video.
Okay.
Yes, ma'am.
am I audible?
Yes, you're
Yes,
audible now.
ma'am.
Yes, ma'am.
Akash, I just want to know that what is the challenges you are already said in your presentation? What is the future scope of your research work?
So currently we have just been working with medical pages, websites, but this
Hmm.
functionality, this framework can be extended for any general web page. So not even just medical web pages, it could be extended to any web page, and it can just provide adaptability in real time to different users based on their preferences and needs.
Okay. Okay, thank you. Very nice presentation.
Thank you, ma'am. Thank you, everyone.
Yeah.
Thank you, sir. Uh, Moving forward, I would like to invite uh, Sir Bizimana to present his paper titled GIS-based electricity fraud detection system using IoT case study, Rwanda Energy Group. Sir, do we have you with us here?
Hello,
Yes.
can you hear me?
Yes, you're audible.
Let me share my screen.
Sorry.
Hello,
Yes, sir, you're audible. You can present.
okay, can you see my screen?
Yes, your screen is visible. You may start presenting.
Thank you very much. My name is Fanny Bizimana. I'm going to present a project entitled GIS-based electricity fraud detection system using IoT, and the case study is Rwanda Energy Group. The presentation outline will be this one. Let's down to the executive summary. Actually, the adequate electricity is the main challenge in low-income countries, reducing the technical and non-technical losses. This one is very important. Hello? Hello?
Yes, sir.
Yes. I'm saying that reduce this non-technical losses is very important. And beyond the detection of this fraud, also the work will help identify the defaulters, the address and the location of the fraudsters, as well as the historical data of electricity, And also, this work will also help the electricity board members to keep the track of all the frauds, the area of frauds, and the area to reach the frauds. And actually, about the introduction, the government of Rwanda is struggling to maximize the electricity access to all Rwandan population by this year 2024. This one was found in National Strategy for Transformation 1, where the rate of electricity was at 40% by 2020, yet the target was to reach 100% by 2024. As we know, electricity is the spine of industries, operation, industries accelerate the country's development. The electricity supply of Rwanda is composed of domestic generation and electricity also from neighboring countries and regional shared power plants. Actually, the energy used from the following sources, we get the energy from the hydropower plants, thermal power plants, the methane gas, and the solar energy. To solve this issue of power deficit known recently, the government of Rwanda has tried to rent some power plants for provision solution. And after this long struggle and a huge investment, the electricity is stolen by some citizens, and this one also may delay the process. The problem statements. Currently, the total loss of Rwanda national grid is equivalent to 19.5%, including both technical and non-technical losses, while the commercial losses triggered due to the electricity fraud is 6.5%, which is equivalent to 1.9 billion of Rwandan francs. Yet to investigate this fraud requires regular inspection, which is cost and time consuming. Sometimes also they inspect those customers who do not steal the electricity. Even when they cut that person, estimation of the cost of stolen electricity is also a challenge. Now, the aim of this research was to design a cost-effective and efficient power fraud detection system using IoT. These are some of the objectives that helped to carry out this research, to assess and study the system requirements, to design a smart cash power detection system, to test and validate the system functionalities, even to monitor the electricity usage of each household. These are some of the solutions for the future of the system, where we'll be computing and display the amount of stolen electricity to show the period or the time of electricity theft, notify the energy utility managers to indicate the location of the fraudster. These are some of the research-related works that was done in different areas, where this Kumar and his colleagues, their topic was contributing on power theft detection and alert system using IoT. Now, one of the challenges that were in that one is that they are not able, sorry, they are not able to compute the electricity which is stolen, and the address of register is also not identified. Duration of the theft is not shown. For the second research paper that which led to this one, but also the gap is highlighted is this one of Xuan Li and his colleague. Also, some of the gaps identified was investigating how the fraud granularity and duration of the smart meter data might affect this privacy, notification of theft missing, compute the stolen electricity. And the third one was about the smart power theft detection system. Also, the gap identified was to compute the stolen electricity and duration of the fraud. The research methodology and circuit diagram. Actually, we started with idea development and the problem statement. Then we started investigating, analyzing the existing systems. Then we proposed the system. After that, we designed the system architecture, the flow chart, the algorithm. After that, we went to the prototype and then the result analysis, even conclusion. For this part, it is about the circuit diagram of how the system will be working, where it is made of two sensors. The current sensors of the input of the meter and another one at the pole. We can be having the controller of 80 mega, we can be having LCD, we'll be having the GSM, we'll be having the GPS, we'll be having the boost converters. and so on. Even the buzzer will be there. The benefits that are associated to this solution is that the energy utility company will easily investigate the electricity stored, reduce the issue of underestimating, even overestimating the cost of installing electricity. And this one also will reduce the case of auctioning due to the lack of fine payments and the electricity cutoff. The real-time monitoring of electricity usage accelerates the electricity universal access to everyone. Reports are kept permanently, even save money and time. About the findings, this is a screen of the device which was made. Actually, this device shows the inconsistency between the input and the output current. Once the difference occurs, the device automatically starts computing the electricity stolen, and the readings will be kept, and the core parameters are data of stolen electricity captured and tested by the current sensors and GPS nodes. And the data are locally presented by the microcontroller 80 mega, and also are sent to the cloud via the GSM to be analyzed, processed, and monitored on the dashboard in different ways. I say that two sensors were used, especially passing it in to compare whether the current received by the second sensor is equivalent to the one in sensor one. If there is a big difference, the device activates automatically to start counting the amount of electricity stolen and send the reading to the cloud in real time. For location tracking, the GPS will be used to indicate the place where the fraud is taking place using the coordinates of longitude and latitude. As you can see, we have the latitudes and longitudes. This is how it will be presented. You can see that we have the cutoff numbers. This one is about latitude and this one is about longitude. And these are the graphs about longitude, how the fraud is being committed in different places. Especially this meter also can be stolen. This case used to happen where the meter is stolen, and after that, the electricity provider will not be able to trace where the meter is exactly located. Now, by the help of the system, now the energy utility managers will be able to trace where the device is really operating currently. And about the data of stolen electricity will be in form of this one, where you see that we have 2.4. This one is an example of electricity, the total current of electricity which is stolen. When you can see on the graph, if you try to point on each device, also on each point, you see the time of stealing the electricity, and when they stop to steal the electricity, even the amount of electricity stolen at that time. And this one is the form of message which will be sent. For example, I'll be saying that Stephanie is stealing the electricity at this. Then you click on this one automatically. Then show you the route going to that person who is stealing the electricity. And this one also happens when someone tries to open the meter, especially when they want to temper the meter. And this message, the second message, this one, Stephanie open the meter. This message also will be sent to the utility managers for just tracking what is happening. Both of the messages are sent to the branch manager of the electricity providers. And also, this one is this is the device which is assembled, and this is about power consumption by the device per month. Actually, it is 3.3 times 10 power minus 3 kilowatts. This one is the amount of electricity that will
This
be.
is a gentle 10 minutes reminder.
That, sorry?
So it is a 10
Hello?
minutes reminder.
Okay, thank you. And the potential impact of this one, just it will come from 5.5%, which is equivalent to this one, and go directly to 2%, which is equivalent to 0.58 billions. Conclusion, actually this research helps to prove that the intelligent device can be incorporated into the meter to track the legal connection and report timely using different means such as short messaging services, compute the electricity, the stored electricity, and send data to the fixed state cloud. And the alarm also is activated when the meter box is open to notify the community and also inform the electricity utility managers of that branch communicating the unusual activity by by indicating the time of illegal connection and disconnection. Illegally showing the consumed electricity. The future work of this one, normally one that the future researchers or the next one should work on biometric authentication for the meter opening of the electricity service, provided in case the meter fails to provide electricity in case of maintenance. Thank you very much for your kind attention. Questions and suggestions are welcome. Thank you.
Okay, very nice presentation. And this is the, I think it is the required work you have presented. And the system you have generated, that is a smart cash power detection system. And you are implementing this system or generating this system for the Rwanda city.
Yeah,
right?
Yes. Yeah, we are trying.
Can we implement this system anywhere in any country and any place or with any organization?
Yes, it is possible.
Is it
We
possible?
can customize. Yeah, it is possible. We can scale up.
Is there any challenge to implement this system anywhere?
The challenges was about getting the
Or
data,
any other basic requirement to implement this system?
no, there is no other requirement, especially it is a small device which is incorporated into the existing meters just to start tracking the illegal activities, especially those ones of bypassing the meter.
Okay. Okay, thank you. Thank you so much.
Thank you too.
Thank you for your presentation, sir. Up next, I would like to invite Sir G. Bisetsa to present his paper titled Predicting Health Stages of Maize Crops by Integrating IoT Technology and Inception, V3, co- convol- Convolutional Neural Network in Precision Agriculture. Do we have you with us, sir?
Yes, I'm here.
Yes. I'll stop
Uh,
presenting. Yes, you can present your screen.
can you see my screen?
Yes, your screen is visible. You may start.
Okay, thank you so much. My name is Gasana Visetsajudisha. I'm here to present the research entitled Predicting Health Status of Maize Crops by Integrating IoT Technology and Inception-based Convolutional Neural Network in Precision Agriculture. So this research has been done together with Dr. Frederic Nzangwengoma, Associate Professor Richard Musabe, Imana Jean-Claude, and Avingabe Claudette. So the outline of this presentation. So we have introduction, the problem statement, the motivation for the research, the objective of the research, system design, implementation and experimental results with a conclusion. So as the introduction, the maize hold significant cereal crops. Sub-Saharan Africa is widely the main source of food produced in both the large scale and limited scale agriculture industries, where in rural areas, majority of the family own the farms, grow maize, and also establishing it as a key stable in East Africa. Locally inside Ndonda, approximately 69% of the country agriculture yields is attributed to the crop's productivity, while the maize crop is accounting for over 50% of that total. So however, all agriculture activities, including monitoring plant growth, tracking health status of the crops, are still being done manually, and the harvest remain at the lowest rate comparing to the process and effort used in this agriculture sector. Trending technology like artificial intelligence and the Internet of Things, through the considering the powerful influence of both technologies, they can be integrated in this sector of agriculture to monitor the crop's healthiness and also the growth of the all stages of the growth, so which will bring high functionality, competence, and a great harvest, which will increase the country economy, satisfaction of the farmers, and also help in fighting against the famines. So on the problem statement, currently the food production becomes a major problem. The growth of population rises from year to year. So it is estimated that by 2050, the world's population will be between 9.4 and 10.1 billion of the people who will be depending on the world's biodiversity of the for living. So the demand for rising for dedicated food harvest area, particularly for livestock and the planting. So the farmers need to increase the productivity in this sector, but they are facing a lot of challenges, especially lack of crop monitoring methods, because it requires to do it manually, analyzing crop health status, as well as detecting plant pest attack at the earlier stage for taking the prevention measures at the earlier stage. A lot of energy is used, a long distances traveled by farmers to visit their farms and check up on their crops conditions and know whether they are healthy or infected, normal, or attacked by the pests, while it is possible to do it remotely without taking much time for physical and manual checking. So particularly in Rwanda, so maize serves as a significant source of income. So, however, the growth of maize is often hampered by the various disease, resulting in decreased yield production, where there is no way of monitoring this situation without visiting physically. So what motivated us for doing this research is we need to monitor the maize crops growth without the physical visiting of the crops field. We need also to increase the inadequate harvest which is being obtained from this field. We need also to contribute in a decrease of the food insecurity in the region, and also detecting the status of the crops as well, the pest attacks the crops. So the research objectives, one of the general objective of this research is to design and develop a prototype of IoT system for capturing maize crops leaves images, which are going to be analyzed by the machine learning techniques and detect whether the crops are infected or not infected, are healthy or are attacked by the pest, to assist the farmers in taking care of the crops in all stages for the purpose of increasing the productivity and the fight for food insecurity. So the specific objective to design and develop the solution prototype for detecting the crops leaves health status and integrate the designed system with the machine learning technique, which is going to be analyzing the health status of the crops. So the diagram we are seeing here is the design of the solution, which is the Raspberry Pi Pi board microcontroller, which is going to be connected with its camera with BME 280 sensor. This sensor will be capturing the humidity at the field, at the crops field. The camera will be capturing the images, and then the Raspberry Pi will be sending the data to the cloud storage. And also we are going to be using GSM model. We have it is the system going to be powered by the battery, and the battery is going to be charged by using the PV cells, so that you can be having the consistency in having the electricity to the field. So the data set is going to be analyzed by the machine learning techniques, so that it can be giving the visualization of how it is detecting the collapse status, and then to send this feedback to the end users. So this the interconnected those components interconnected together. This design used by a fleeting platform, interconnecting those sensors and the sensor microcontroller and the cameras together with together, so that they can be performing as a prototype. So the implementation and the start, so it started with the prototyping. We developed a prototype which we used to capture the data, the images data from the field of the maize crops, so that those images are going to be used for training the model of the machine learning. So the data has been collected by using the prototype, and also machine learning model prediction has been for prediction has been developed. So we developed they use the three techniques: the transfer learning, efficient net, and inception history of neural networks, and then here it is the comparison of their performance. The transfer learning, it is having the accuracy of 79.7% with the loss of 50%. Then also we have the inception V3 model, which is having the accuracy of 99% with the loss of 2% for the data. Then you have also the efficient net teachers having a class of the 96% with the loss of 13. So the best one which is performing well on the image analysis in order to detect whether the crops has been affected or not affected, they are in normal status or not. So it is the inception V3 model of convolutional neural network in the machine learning. So she's having a class of 99%. So the graph representing how the training and validation accuracy and also training and validation loss. So the accuracy in general accuracy is 99%, and then the rest is 2%. This is for the exception V3 model, which is the model which is working well, better than other models you have tested. So, as conclusion, during this research, the IoT-based prototype has been developed and used to sense the data from the maize crop field, and the collected images that are analyzed by efficient net exception V3 model, transfer learning, machine learning models for deep learning, and convolutional neural network for image processing, analysis and classification of predicting the health status of the crops. So, as the main source of the human effort is coming from the agriculture sector, this system will highly contribute to the crops condition monitoring and helping in fighting against the famines in developing countries like Rwanda due to the agricultural activities implemented with the use of technologies increase the production at the higher level. So this work can be integrated, can be what we consider as a future work. We can just combine what you have now, then we make sure that we are combining with the method which can help in distributing the insecticide once the system is detecting that there is a pest which is attacking the crops. So this is the list of reference. Thank you so much. Welcome question and the answers.
Okay, very nice presentation. I want to ask that what challenges you are facing to implement this system, because this system is related to environment, soil and all. So basically, what challenges you are facing related to this?
So there's some challenges related to the environmental factors. Like for collecting the data at the beginning, the prototype has been spoiled due to the heavy rain. So that was one of the challenges. So getting data set was not easy. Just required to get the good climate and the good weather.
Okay. Okay, thank you.
Welcome.
Thank you, sir, for your presentation. Next up, I would like to call Sir Makonde Moal to present his paper titled Secure Mobile Payment Gateway for Higher Institutions of Learning. Sir, do we have you with us here?
Yeah, my name is Makonde Moal from Zambia, University of Zambia. I'm presenting on a secure payment gateway for higher institution of learning. So I'll quickly jump into introduction. So the background is higher learning institution still rely on manual processes. So let me just minimize the toolbar. Okay. So the background is the higher learning institutions still rely on manual processes for payments, which allow the student needs to visit the payment institution point. And then later, once they visit the payment institution point, it will allow students to pay school fees in those institutions such as banks and other payment segmented points. And these payments were proven to be effective during a busy period like registration and exam fees due to long queues and inconvenience in the payment designated points such as banks. And also due to crowded, it has got high risk to pose a COVID-19 infection. So the problem statement is, with the increase of student enrollment in higher institutions of learning, the registration and payments of student fees have become a challenge marked by long queues, inconvenience, and overcrowded at designated financial institutions. In addition, crowded queues for payments at these institutions pose high risk of COVID-19 transmission. According to the World Health Organization, recommends to avoid transaction and contact-based payments such as cash. So the aim for this research was to identify the key payment mode used by higher learning institutions and to design a prototype of the secure payment gateway for these institutions. Then the major objective is to identify the payment modes used by higher learning institutions and the challenges faced by students when using these payment modes. Then also to design a model for a secure payment gateway based on the payment modes. And the last objective is to develop a prototype based on based on the model described in 2 that support these payment mode mentioned in point 1. Then the research questions were, what are the major payments modes used by higher learning institution, and what are the challenges faced by the student when using this current payment mode? Then how can we come up with a secure payment gateway integration model based on the payment modes? And how can we build a prototype based on the model in item number 2? But the overall point of this study was to aim to enhance the overall payment experience, which is to increase the efficient, reduce the administrative, and simplify reconciliation and eliminate the needs of students to wait in queues at the bank to pay the school fees in higher institutions of learning. So the study area, inconvenience sampling was employed for selected higher learning institution, and few higher institutions were selected, which is the University of Zambia, the largest university, Evelyn Horn, the largest college, and also NIPA, which is the public administration college. The reason why these institutions were selected is due to other practical considerations, like time constraints, budget, and other logistics, because these institutions were easy to access. The limitation of this study, the prototype implementation will only be focused on the University of Zambia to enable merchant application within the school to seamlessly integrate into the payment gateway for payment processing part. After the development of a prototype, simulation were employed for integrating with banks and mobile operators due to delay in approval within MNOs and the national switch to get access to user acceptance environment. Then I'll proceed to literature review. So literature review are technology acceptance model and unified theory on acceptance and use of technology. These 2 were selected and applied to the research. So these are just key diagram which demonstrate the technology acceptance model and the unified theory on acceptance and the use of technology. So research, few research were done, and based on the other research which were done in the past, there's someone who implemented the design and implementation of electronic payment gateway for development country. The paper findings, the paper presented the experimental result of proposed electronic payment gateway, and it was more secure, more cost effective, and it used encryption standard, triple data encryption standard than the other existing system. And in the gap, the study lacked the comprehensive framework and did not capture various dimensions and factors of digital payment technology and their associated challenges, and proposed system only supported card. Then number 2, another research on effective of student electronic payments, a case study of the University of Zambia. The findings were the existing system payment system at the University of Zambia had limit, as students had to physically present on the campus for payments and registration process. A gap in this study was the study did not explore the factors influencing students to adoption of the payment system. Then the other researcher discussed on the secure and robust web service of e-payments of tuition fees. So this one, the finding, the overview of the e-payment service was based on the REST web services to explore the system security, robustness, and performance aspect. In addition, the paper also had comprehensive analysis comparing the service features and cost with other related works. It highlighted the system performance with higher percentage of success of e-payment and minimal error rate. But there were also gaps. The study did not provide any methodology, and the performance of the web services such as response time, availability, scalability, and performance evaluation could help to assess the effective and efficiency of the web services and identify potential areas. So the baseline study, the system design was close section design, methodology, which is quantitative approach. Then the sampling was, random sampling was adopted for selected hostels at a higher learning institution. Those occupants were then selected for participating in this study. Then the sample size, it was 246 with a confidence level of 95 and the margin error of 5%. Data collection was close-ended questionnaires administered by the researcher, and also data analysis. The primary data was from questionnaire and then analyzed through the analyzed softwares and Excel, which is SPSS. So the current process, the student will visit the bank, then the student will join the queue, then they'll approach the payment counter, then they'll provide necessary details to the teller, then the teller will process the transaction on the core banking system.
This is a gentle 10 minutes reminder.
Sorry?
So it's a 10 minutes reminder.
Okay, let me just quickly wrap up. So then the student will get a receipt, then they'll need to go back to the institution at the account departments to present proof of payments. Then they can locate the payment in the system. So the proposed system is that the student, they'll be able to pay anywhere. The university system or the college, they'll connect to the university applications, will connect to the payment gateway for any payment processing. Once the payment process, the integration is done, then the system will connect to third-party integrations such as bank, mobile operators, and also card, so that it will allow the student just to pay directly on their mobile phone or web application. The payment gateway is open for a number of integrations. It allows to create an account for each application and also to pass transactions. So this is the high level of the payment gateway. The user interface, it can be a mobile app or a web application. They need to connect to the merchant server, Then once it connects to the merchant server, the back end of the merchant server will connect into the payment gateway, and it provide different microservices. So the prototype was developed in Go programming language and also uses MySQL as a database. And the services were tested using Postman. Then the code repository was Git, and it was hosted on Ubuntu 22.04, and the web server was Nginx. So that's the use case. I'll quickly move. Then the security part, the payment gateway key security part
Sorry
is
to
such a.
interrupt, sir. Can you please conclude the presentation as we have crossed the 12 minutes mark?
Okay, let me conclude on the results. So these are the results of the questionnaire. With wastage of time in the banks, it shows all the payment methods available, and also long queues and overcrowded in banks, and also key payment mode used by student, and also the exams. So these were the results from the questionnaires. And this is the prototype. So this is the administrative part where they can log in, define the merchants, and they get the access to the web services. So the available web services in the payment gateway is authorization, which is get token access, get available payment method, submit a payment, get a transaction status, and report. The other screen shows the encryption, and it was tested in test environment, a number of students, which shows that successful transactions were taking about 4.5 seconds. Then average failed transactions were taking about 4.3 due to timeout or insufficient funds in the student wallet. So recommendation, the major focus on the recommendation could be to incorporate with technologies such as biometric authentication to enhance security features, also to support card and bank payments, since as at now it's only support mobile payments, and ongoing optimization effort that will further improve the scalability and ensure that the system can effectively accommodate the need and growth of the user base and increase the transaction volume. Okay, so these are the reference. At this point, I'll take questions.
Yeah, very nice presentation. It is a secure payment gateway system, right?
Yes.
I want to know that what features you have added for the security point of view in this system.
Okay, so let me just quickly go through. So the one of the item which was added was the advanced encryption standard, which is AES, and also the other thing which was added was the SSL, the secure payment gateway. Then it was also working on TLNS, the transport layer, and also whitelisting of APIs, and also tokenization. And when now you look at the application level, their parameter validation, and also allow and listing deny, which talks to whitelisting and authentication also, and also limit of the request.
Okay. Okay, thank you.
Thank you.
Thank you, sir, for your presentation. And last, I would
Please,
like, yes.
please.
And
I had the connection problem. My paper is per topic. Can I present here now?
yes, ma'am, you can present your paper titled Bird Topic LDA Model for a Bidirectional Recommendation System towards Matching Jobs in Job Seekers.
Okay, thanks. Good evening, ladies and gentlemen. Thank you for your attention today. Just let me share with you my presentation. So, So, I repeat again, good evening, ladies and gentlemen. Thank you for your attention. Today, I will present to you my paper entitled Per-Topic LDA Model for a Bidirectional Recommendation System to Award Matching Jobs and Job Seekers. First of all, I will present to you a short introduction, which include our main problematic and our objective. Second, I will mention the related work and our contribution. Then I will show you the results of our experiments that we obtained. Finally, I will finish with the major perspective of our work. So, recommendation system is an information filtering technique which provides user with information which he or she may be interested in. Recommendation engine are applied in variety of application like travel and tourism, books, movies, education, TV program. However, there are also newly applied in human research for fresh and employer who are looking for suitable candidates. In fact, our recommendation system is used to identify potential candidates for a given position. Most required have difficult to find the profile that they search. So our main problematic are that take complex decision regarding several aspects of a given case. Required are faced with the shortcoming of the current research tools offered by social network and service. Also spend hours and hours to seeking for pertinent candidates and pertinent offers. The search stage are particularly demanding in terms of time and research and place the requirement in unusual commission position next to potential candidates. So our main goals are automatize the requirement process, design of tools and intelligent monitoring and dynamic of the files of requirement, improve the collection and aggregation of information on candidate from LinkedIn, analyze the restriction of information from jobs offers and the profile extracted, the matching between candidates and job offers. As we know, there are many approaches that have applied in research in the recommendation system. We can mention in 2018, Bilser and al. Proposed a solution based on collaborative filtering using cosine similarity. In 2019, Twockley et al. Implemented stock market prediction using the machine learning libraries, MLib. So our SPAC achieved a good running time. In 2020, according to Elements et al., they use data augmentation technique to improve the machine learning performance and to train the model. In 2021, Jusher and Dutton et al. Gives importance to data volume in recommendation system and especially in the training phase. Also in 2021, hundreds have the same give importance to data volume in his solution. Sorry. So the use of topic model in statistics and NLP involved in defining latent topic in corpus of document through a probabilist generate model. So we have two algorithms, LDA and bird topic. What's LDA? Latent Directional Allocation. According to Gilder et al. 2019, LDA is recognized as the most advanced topic modeling technique, and it is a powerful tool for textual analysis that utilize statistical correlation among words in multiple documents to determine and quantify the underlying themes. Conforming to Elborn and Bergdon in 2023, every document can be interpreted as a probabilist distribution over latent topics. All documents have a common dataset prior for the topic distribution. A probabilist model is used to represent every latent topic in the LDA model. The topic shares a common Dirichlet priori for their distribution of works. LDA is not model. The topic share a common Dirichlet is not slowly about describing a probabilist model for a corpus that assign a high probability to certain members of the corpus. So, for the bird topic is an advanced topic modeling technique introduced by Growth Sentence in 2022. The acronym BERT topic represents the goals of the algorithm by combining both bidirectional encoder representation from transformer and topic, extracting relevant topics from text dataset. BERT topics innovation is driven by the use of BERT embedding, which learn word representation contextually from a large corpus of text through a deep learning neural network. This embedding can be used to capture the rich conceptual information of every word in a document. The semantic meaning and contextual relationship between words can be captured by BERT topic to gain more accurate topic modeling. BERT topic also employs a prediction called CTF-EDF that use a class-based term frequently inverse documents. So, our module, our contribution are collect public profile and job offers from multiple world source like LinkedIn, KillJobs, and Indeed. Improve the quality of data used by recommendation system. Use the two-topic modeling algorithm BERT topic combining with the latent directed allocation LDA. An overview of the proposed system is shown in this figure. Job posting and user profile data are used and input in our process. The generation of candidate profiles and jobs is achieved through pre-processing and training phase. In the end, matching is carried out to create a list of job recommendations for employees and recommendation for job seekers. Our solution is constructed into various modules. Firstly, data scraping, data processing, development or topic model, training and validation model, and bidirection matching. Firstly, we collect data from multiple web search, LinkedIn or Indeed, using web scraper. The process of web scraping for all web search cannot be standardized to the structure of each website. To achieve this, we employ Python programming to automate or construct web crawlers. The data is analyzed using Beautiful Soup and Node.js, and then it's sorted in a local JSON file using Selenium WebDriver. Besides, the pre-processing layer involved removing punctuation and URL, lower text, removing stop words, tokenization, limitization, text duplication, and text normalization. We used the centrist form to remove the interference and to improve the accuracy of topic module. However, in this project, two topic modeling methods are employed, the LDA and the BERT topic, combination the two algorithms. So, this is an example of our data scrapped from LinkedIn. It's a JSON file. We process two sets of data in JSON format, on that pertains to user profile and the other that pertains to job profile shown in these figures. Experiments are aiming to identify topics from a vast text corpus. Scrapped data was utilized for our experiments. Processing techniques are applied to the subset of data that has been collected. In the following stage, the knowledge retrieval techniques that measure term frequency and its inverse document frequency is calculated from the processing document. Identification of topic is achieved by passing the TF-EDF vectors to the LDA and BERT model. The embedding are reduced in dimension due to clustering algorithms failing to handle high dimensional to decrease dimensionally. The TSNE PCA and UMAP algorithms are applied to evaluate results with reduced dimensionality. The K-means clustering methods is employed. Scikit-learn and NLTK tools are utilized for conducting machine learning experiments. The results are evaluated based
This is a
on
gentle
silhouette
10
of.
minutes reminder.
I don't listen.
Ma'am, it's a 10 minutes reminder.
Okay, just a minute. So there is our experimental results. We use PCA, TC, and UMAPs. Firstly, we use LDA algorithm besides bird topic, and finally we combine LDA and bird topic, and we obtain the best result compared by LDA only and bird topic only. This is so. To conclude, our proposals in this project is a bidirectional job recommendation system, reducing the amount of irrelevant applicant would leave it. Our recommendation system are proved to be efficient for human research to facilitate the requirement process. Results from this project indicate the advantage of combination LDA and work topic. Thanks. Thank you.
Okay.
So,
Sharma, what is the future scope of this system?
you can repeat to me because I had a problem in connection. I don't listen to you.
Am I audible?
What?
Sharma, am I audible? I think there
I
is
don't listen to you. Sorry. You can repeat to me your question or your remark?
Yeah, what is the future scope of this system?
This system use scraped our benchmark. We have scraped the data from LinkedIn. So not all data just not private profile. So after that, we have a big data benchmark. We use LDA topic modeling to this data. LDA and world topic combining the two algorithms. The outcome will compared to algorithms that already exist. LDA exists, bird topic also exists. We compare the two algorithms and we combine these two. They perform better. So this is our contribution is the combining of firstly we scraping data from LinkedIn. Secondly, the combination of two algorithms, LDA and bug topic modeling.
Okay, thank you.
Thank you. Thanks.
Thank you, ma'am, for your presentation.
Thanks. Thanks to you.
Sorry. I sincerely would like to thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support during this ninth version and all the previous eight versions of the conference. We will be happy to have you in the 10th version in 2025 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to this printer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also would like to thank our session chair, Ma'am uh, Ma'am Vijeta Kumawat, for chairing this session. Thank you so much, ma'am. This is a small token of appreciation for you on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Before we conclude, I would like to request ma'am to say a few words to the participants for the session.
Thank you, Priyanshi. I have always a new experience as a session chair in your conferences. Today, I have again a very wonderful experience and very wonderful paper listen in this session. And I congratulate to all the presenters for their research work and their future research work. Thank you for inviting me as a session chair.
Thank you, ma'am, for your valuable time and presence. At the end, I would like to request everyone to switch on their cameras for a quick snapshot of the virtual conference. Yes, is everyone ready? Okay. 1, 2, 3. Thank you so much, everyone. Stay safe, stay connected.